Hello everyone, welcome back. I've brought you another problem. It's a miscellaneous problem based on arithmetic progressions. It says that if p is not equals to q, then the sum of first p term is equal to the sum of first q terms. And if this is so, then prove that s p plus q is equals to 0. That means the sum of first p plus q term is equals to 0. Alright, so let's do it. It says that if the sum of first p terms of AP is same as the sum of first q terms, so basically we are dealing with sum of terms over here. So I've written the formula sum of n terms is n by 2, 2a plus n minus 1 into d, right? So this is given as p is equals to sq. So I've put p in this formula instead of n. Rest all of it is same and I have equated them. Alright, this 2 will cancel out and this p if multiplied will get me this term, and q if multiplied with this bracket will get me this term. Now I have bring this a terms together, so 2a will be common and I'll left with p minus q. Alright, similarly this d, this whole expression will go over here because d and d they are same. Alright, so they'll be in minus over here, so I'll be left with q square minus q, and this term in minus, so sign will change, so I'll get minus p square and plus p. Alright, if you clear this out, then put it down in comments. So q square minus p square, here this expression can further be expanded as that's a square minus b square, a plus b, a minus b. Similarly, I can write it as q plus p and q minus p. Alright, now again I have rearranged it. This I've written over here and this I've written over here with a change that I've taken minus sign common out of them. So this expression which was plus before, now it's turned into a minus sign. Alright, I hope this one is clear. So after that, if you notice, p minus q is common, I've taken p minus q common, and now when p minus q is common it can be cancelled out. I've cancelled it out, and so now I'm left with 2a is equals to d 1 minus p minus q. Alright, this will be my equation number 1. This is my equation number 1. So now because I have to prove that sp plus q is equals to p plus q upon 2, 2a plus this will be my formula. Alright, for sp plus q I've applied it. Instead of n I've just put p plus q. Alright, and here I have already the value of 2a. I've put it over here. Now if you notice, take minus sign out from this bracket, you'll be left with p plus q minus 1, and we already have p plus q minus 1 over here. This is in plus and this is in minus, so it will cancel out to 0, and 0 multiplied by something is also 0, hence verified.